Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on Thevenin's theorem. For the following network, using Thevenin's theorem, find current flow through 5 ohms resistor. According to Thevenin's theorem, any linear complex network can be represented as an independent voltage source VTH in series with resistance RTH. So to find Thevenin's equivalent circuit, we have to find VTH and RTH, Thevenin's equivalent voltage and Thevenin's equivalent resistance. Before applying Thevenin's theorem, we have to divide the network into two networks, network A and network B, which is the load. So here network B is 5 ohms resistance. So we have to remove 5 ohms resistance from the circuit. To find Thevenin's equivalent resistance RTH, all independent sources in the given network must be replaced with its internal resistance. So here the voltage source is replaced with a short circuit. If we analyze the network carefully, we will find that 100 ohms resistance is in shunt with 6 ohms resistance, and the shunt combination is in series with another shunt combination which consists of 15 ohms resistance and 8 ohms resistance. So we will get RTH is equal to 100 ohms parallel to 6 ohms plus 8 ohms parallel to 15 ohms. We will get RTH is equal to 10.88 ohms. Thevenin's voltage VTH. The open circuit voltage of the circuit VTH can be written as VA minus VB. So to find VTH, we have to find VA and VB. VA is the voltage drop across 6 ohms resistance. So VA is equal to current flow through the series combination of 100 ohms and 6 ohms into 6. So we will get VA is equal to 100 divided by 100 plus 6 into 6. So VA is equal to 5.66 volt. Calculation of VB. VB is the voltage drop across resistance of value 8 ohms. So we can write VB is equal to current flow through 15 ohms and 8 ohms into 8 ohms. So current flow through the series combination of 15 and 8 ohms is 100 divided by 15 plus 8. Therefore voltage drop across 8 ohms resistance due to this current flow, VB is equal to 100 divided by 15 plus 8 into 8. So we will get VB is equal to 34.78 volt. So we can write VTH is equal to VA minus VB. VA is equal to 5.66 volt and VB is equal to 34.78 volt. Therefore, VTH is equal to 5.66 minus 34.78. We will get VTH is equal to minus 29.12 volt. So the given network can be represented as series combination of Thevenin's equivalent voltage VTH and Thevenin's equivalent resistance RTH, where VTH is equal to minus 29.12 volt and RTH is equal to 10.88 ohms. So current flow through 5 ohms resistance can be written as I5 is equal to VTH divided by RTH plus 5. So I5 is equal to minus 29.12 divided by 10.88 plus 5. So I5 is equal to minus 1.83 ampere. So current flow through 5 ohms resistance is minus 1.83 ampere. Thanks for watching Circuits Analytica. Enjoy learning.